Hi friends, I am Vijay Solanki and you are watching Something of Everything.
Hi there. In this video, we will see how to design Raft foundation and STAAD foundation. As you can see, if the analysis has been completed, click on foundation design, click on the load combinations that you have to select to take them into STAAD foundation. Once the combination has been selected, click on include and click on run STAAD foundation. The support reactions as well as for the load combination selected shall be transferred to STAAD foundation. And you can see the geometry. In the inputs, you can see the input has been completed. Once that has been completed, you can change the view options and select the stresses, loads, plates in different colors. Let's say let us say yellow. As you can see now the yellow forces. Once it has been completed, just now this click on the foundation plan. Set the column positions. As you can see, and the column sizes. If you want to add the pedestal sizes, click on this and add the sizes as option. In the load options, click on plus center, select all, press OK to add the center of the structure. Click on load factors and in design factors, as per load combinations, change the factors. As we have imported the service factors, all we have to do is we have to give factor for the design. These are as per Indian codes. You have to see your own code for which you want to check it. After that, click on soil bearing capacity factors. For that plus line we shall have 1 and for the rest we will be applying 1.5. You can adjust the columns widths by selecting the top and pressing it. Except that plus line, the load soil bearing capacity factor shall be 1.5. You can find them in management table number 1. Once that has been completed, click on job creation, click on create job. In our case it's a Raft job. Click on match, click on Indian, click on the SI units will be coming and include the load combinations. Include all the load combinations and create the job. Click on create job. As you can see, the job has been created. You can see the Raft job name as well as the combinations that have been imported here. In the job, click on the default parameters. You can change them as you want. You can add the physical beams if you want to add the beams in the Raft foundation. If you want to add the piles, you can create the pile layouts. In our case, we are only designing the Raft foundation, hence we will not focus on beam as well as pile. For Raft mat geometry creation, click on mat foundation, click on add geometry. You can add rectangular or polyline. In our case, let us add rectangular region. Click on rectangular region. In the right side menu, in the region, all you have to do is you have to select the units. You have to give the top left corners coordinates. In our case, it shall be the coordinate of the first node is 0, 0. Hence, let us put a raft of 2 meter offset from the extreme nodes. So the lower left, top right to top left corner shall be -2, -2. The length of the raft shall be length between the nodes plus 4 meter. As you can see, it is 12.77. Hence the raft length shall be 16.77. And in the Z direction, it shall be 11.29 plus 4, that will be coming out to 15.29 and z shall be minus 1.3. Click on add region. As you can see, a blue line has been created. That's the boundary of the raft. In the meshing setup, you have to select the boundary. You have to give it a name. In our case, it's a raft. Press add. You can also add holes and control region if you have created a boundary for the same. And control region. In region, you can give different parameters than other raft. Let us say, in our case, select the raft, change the unit, select the raft, select the unit for which we want to create the transitions, create 0.5 meters meshing, optimize the meshing, click on generate meshing. You can create quadrilateral meshing, quadrilateral as well as triangular meshing and triangular meshing. Let us create quadrilateral meshing, create the nodes, add support, and let us take rest as default and click on OK. The mesh has been created. As you can see, the mesh is of that of rectangular mesh. Once that has been completed, click on analysis properties, click on slab thickness. You can change the thickness. In our case, let us say we design 0.45 meter raft thickness. And in soil parameters, soil properties, you have, as you are designing the raft foundation, you have to use the soil subgrade modulus. The soil subgrade modulus shall be provided by the soil expert. If not, you have to ask him to provide the same. In our case, let us say the soil subgrade is 20,000 and the soil height above raft. Our raft is 2 meter below the soil in ground, original ground level. Hence, the soil above the raft shall be 1.55. That comes out from 2 meter minus 0.45 meter raft thickness. And give the soil density. And the unit soil density of that. Once this has been completed, click on Analysis and Design option and click on Analysis. Okay. Press yes and wait for the analysis to complete. It will take some time. Once the analysis has been completed, until then we have to wait. We will wait some more time. It takes some time to analyze so many of meshed flats. And then you can enjoy the isolated and combined fitting videos. You click on the top right position. Once the analysis has been completed, as you can see, the deflection diagram is being shown. In the output, you can see the analysis process that has been completed. You can see the tables of displacements, displacement summary, reactions, reaction summary, contact area if loss is there, any place stresses, as well as place stress summary. If you want to see it graphically, click on Output View options. As you can see nodal displacement in different color. You can see the average values. You can see the beam displacement if you have given the beams. You can draw the line diagram as well as 3D diagram. In our case, let us put line diagram. You can click on Let Stress Show. In the drop down menu, you can select the stress or force that you want to see. The legends, you can see the values, and the plan, you can see the diagrams with the color coding, based on which you can see the different values. You can see the MY values. You can see the soil pressure. By clicking on the soil pressure, as you can see, the soil pressure is being shown graphically, as well as legends are shown in the left. You will be thinking for which load combination it is coming. To check the load combination, you have to go to the top. For that combination, the base pressure has been shown. Let us find the cursor of the plate so that we can select the plate and check if it can show the individual plates stress, but no, it is showing the geometrical properties, not the stresses. Let us check another cursor if it works. No, it's not working out that way. Let's check it again for the plate. It's showing only the geometrical properties. Kindly bear with me so that I can explain it more better, in a better way. Wait okay. So it is not showing the individual plates result, it's showing the color coded results as well as the legends in the left. If you want to hide the legends, you can click here. To view the legends, you have to check path tags. Okay. You can see the results in the deformed shape, but in our case the deformation is not so much, hence it is not being seen visually. You can change the load combinations in the pressure diagram, so it changes as per the different cases. In our case, it's coming the same almost. In the plate stresses and results, you can change the results. If you have been provided, you can see the beam results also. Once that has been completed, all you have to do is you have to do the moment envelope generation. Let me try again if it can show the base pressure. No, it's not showing. Let's go to the moment generation. This will create the moment envelopes for which the design will be done. All you have to do is you have to select the boundary. Now you do not need to select the boundary, I guess, because in the right side task pan you can see that you can, in the drop down menu, you can select the boundary. The major axis shall be X. It will be the longitudinal direction. If you want to change it to Z, you can by clicking on along Z axis. And let's divide the zones to 100. Let's, in the other direction also, let us create the zone of 100. We will divide the plate into 100 different plates. Let us create for all load cases. It will create the load envelope for which the design will be done. Once the envelope has been completed, you can see the rectangulars for which the zones have been created. And the design parameters. Okay, let me just stop the stress diagrams. By clicking again on the stress diagram menu. Click here. Yes, okay. The stress has been stopped. Now let us go to design parameters. And change the parameters as per your project specifications. And let us say in our case it is M20 and F500. Let us change the covers to 50 mm. This all the data shall be as per your design preferences. Okay. Let us put maximum to 16 mm. maximum spacing to 200 mm and minimum 200 mm. All these parameters shall be as per your design preferences. Now click on design to design the raft, and you can see the design summary. The reinforcement requirement, maximum top, maximum bottom, as well as in the transverse direction. Okay, and you can see the detailed report, in which you can see the longitudinal report for the governing load case, required reinforcement area for the moments and at the locations. For each zone, moment zone envelope column created. You can also see for the transverse directions in the bottom and top. You can scroll up and down for the reinforcement requirement change. Okay. You can scroll down. Also, as you can see, it's changing from 360 to 440 as per moments and reinforcement requirement. You can also check the punching sheet for the service load case. You can see the stresses at the corners and the check that whether it is being passed or not. Okay. You can print it also if you want. Once the design has been completed, you can do the reinforcement zoning. Reinforcement zoning is nothing but providing different layers of reinforcements. Let us say at longitudinal top direction, bottom direction, you can change the reinforcement. Let us say 3 reinforcement zone. Click on the create zones to see what happens. As you can see, it has created 3 zones of reinforcement. For the blue ones, the reinforcement requirement is at total at 139.44 mm. That is sufficient enough. In the green zones, it is 12 at 128, and in the red, it is 16 at something. This way, you can see the reinforcement arrangements that you can provide for different zones. You can see the report also. As you can see, the blue will be at or at 140 around. You can also do the reinforcement zoning as per reinforcement requirement. If you click on reinforcement requirement, it will be showing the zones of the requirement of the reinforcement. As you can see, it is showing now 0.558 square inch per feet. Let us change the unit of this. Let us change it from the display units. Let's make it to SI units. Let's click here. See if it changed. No, it is not changing by that. Let's click here SI units and check whether it's changing or not. It is still not changing. We will have to find out where to change the reinforcement zone. Check. There is no option for that. It's not working out this way. We shall have to convert this I guess. These are 50 zones, different zones that you can provide. Reinforcement. It's not changing. Let us put it as it is. And for different cases, you can see the reinforcement requirements as per the zoning. As we have reset the zone, it is showing 3 zones only. In the bottom also, it is showing as per the zonal requirements for different cases. Once it's completed, you can cut the slabs and see the results in the linear format. Let's draw the line for which we can see the stresses, forces, etc. Once the line has been created, let's do MLX for the sun. As you can see, zoom in, and you can see the governing moments in this line cut plane of the raft in the diagram as well. You can change the MLX to MLY, and it will be showing in the graphically in the contour because the forces have been created. You can design this line as a linear manner. It will be showing the moment envelope. It will be showing the reinforcement required once you design the same. It will be easy without it. This way you can design the strips also. And if you want to check the moment capacity, you can click here, and for the provided reinforcement you can check the pile plate moment capacity. And last, calculation sheet. You will see the calculation for the raft that has been calculated. Thank you for watching this video. Do like, share and subscribe our channel, and yeah, don't forget to comment and review our video. If you have any query, post it in